Hello my dear students, my name is Neha Yadav and I am Assistant Professor in Noida Institute of Engineering and Technology, Pharmacy Institute. Today I am going to deliver a lecture on topic that is solid, crystalline, amorphous and polymorphism. It is from the Physical Pharmaceutics code BP30T. Okay. So, in our earlier classes we already discussed about the state of matters, in which we have discussed the solid state, the liquid state, the gaseous state and the last is liquid crystalline state also in our previous lecture, okay, as well as glassy state also. Okay. So, in our today's class we are discussing on three broad topics. The first topic is solid crystalline, another is amorphous and lastly polymorphism. So, would like to continue with our first thing, that is solid crystalline. What is solid crystalline? Solid crystalline, it is a crystal or a crystalline solid is a solid material whose constituents such as atoms or molecules or ions are arranged in a highly ordered microscopic structure, okay, forming a crystal lattice that extends in all direction. So, what do you mean by crystal? I already told this definition or already discussed this in my previous lecture. So, what is crystal or crystalline solid? It is a solid material whose constituents, and constituents are either atoms or molecules or ions, they are arranged in highly ordered microscopic structure, okay, and then they form a crystal lattice which extends in all the direction is known as solid crystallines. Okay. For example, we have diamond, galena, quartz, pyrite, okay, and here you can also see the diagrams of the things like quartz is there, pyrite is there, as well as galena is also there. You can say this is galena. Okay. Moving to the next, we have crystals have definite and regular geometry and have long range as well as short range orders of constituent particles. So, crystals का क्या होता है? They have a definite regular geometry as well as long range and short range of a particles also. तो उनका एक definite as well as regular geometry होता है जिसमें कि या तो long range होगा या short range होगा जो भी particles उनके अंदर हैं, ठीक है. crystals का जो है high melting point होता है, they possess high melting points. The crystal external forms have regularity when these are formed, okay. जब ये बनते हैं मीन्स क्रिस्टल्स जब फॉर्म होते हैं तो उनमें क्या होता है, एट द टाइम ऑफ फॉर्मेशन दे आर एक्सटर्नल फॉर्म हैव अ वेरी मच रेगुलर मॉइटी. वो रेगुलर फॉर्म में रेगुलरिटी होती है उसमें, जिसमें उनके जो मॉलिक्यूल्स हैं जो बाहर से आकर अटैच्ड होना शुरू करते हैं, दे आर इन द फॉर्म ऑफ in a manner of a regularity, regular manner में they comes and attach from the external crystals. They give a clean surface after cleaved with knife. अगर आप उनको knife से cut करते हो तो the topmost surface is always clean, okay. When you will cut a diamond you will always see a smooth, you will cut a pyrite you can see a smooth surface on the top, okay. They have definite heat of fusion. So, solid crystals का क्या होता है या solid crystallines का एक definite heat of fusion होती है, okay. Crystalline solids have very rigid and their molecules can be deformed by mild distorting force. तो जो आपके crystalline solids होते हैं वो बहुत ज़्यादा rigid होते हैं, हाँ, और जो उनके molecules होते हैं वो बहुत जल्दी से ही डिफॉर्म मीन्स ब्रेक नहीं हो जाते हैं. अगर हम उनको थोड़ा सा भी डिस्टर्ब करते हैं या डिस्टॉर्टिंग फोर्स अप्लाई करते हैं तो उससे उसके मॉलिक्यूल क्या होते हैं, बहुत जल्दी से डिफॉर्म नहीं होते, मीन्स ब्रेक नहीं होते हैं, बिकॉज दे आर वेरी रिजिड, ओके. सो crystalline solids are considered as true solids. अगर हम बात करें true solids की तो we can say crystalline solids are true solids. Now crystalline solids displays anisotropism. What is anisotropism? Anisotropism, it is the characterizing substances that exhibit physical property with different values. Okay, they possess physical property with different values where they are in different direction, where they can measure in their different directions, is known as anisotropism. Now we have, with few exceptions, the particles that compose a solid material, whether ionic, molecular, covalent or metallic, are held in a place by strong attractive forces between them. Okay. So, when we discuss solid, therefore, we considered the position of the atom. Okay. When we will discuss about any kind of solid, we always consider the position of the atom, the position of the molecules, the position of the ions, which are essentially fixed in the space, rather than their motions. Okay. So, which are very important in the form of liquid or in the gaseous state. Okay. The constituents of solid can be arranged in two general ways. They can form a regular repeating 3-dimensional structures, okay, that is our pneumatics, called as crystallytics, thus producing a crystalline solids, or they can have aggregate with no particular order. Okay, they form aggregates but उनका कोई भी एक particular order नहीं होगा, in which case they are in the form of amorphous solid. Amorphous solid मतलब disordered arrangement of the molecules, ions, atoms. Okay. So, what is amorphous? In a Greek form, amorphous meaning shapeless, okay, which do not have any shape, we can term that is amorphous in nature. So, crystalline solids or crystals have distinctive internal structure that in turn lead to a distinctive flat surfaces or faces. The faces intersect at angle that are characteristic of the substance when it is exposed to X-rays. Each structure also produces a distinctive pattern that can be used to identify the material. Okay. So, characteristics angles क्या है? Characteristics angles do not depend upon the size of the crystals. Okay. तो crystals के size पे ये depend नहीं करता है angle. They reflect to the regular repeating arrangement of the component of atom. It depends upon the regular arrangements. किसकी? Atoms की regular arrangements पे, either molecule की regular arrangements पे या ions की molecular arrangements पे in space, the characteristic angle depends. Okay, it will not depends upon the size, but it definitely reflects on the arrangement of the component of either atom हो या molecule हो या आपके ions हो in the space. So, when an ionic crystal is cleaved, repulsive interaction occurs. Okay, to break along fixed plane to produce that in the angle same of those in the original crystals. Okay. So, moving to the next, we have in a covalent solid such as cut diamond. Okay, the angle at which the faces meets are also not arbitrary but can determined by the arrangement of the carbon atom in the crystals. So, this is you can say here, this is the cleavage plane. Okay, here are you can say atoms or molecules are arranged. If we apply stress, okay, from both the direction, stress is applied from here also, stress is applied from here also, then what it done, if it applies the stress, repulsion take place, the molecule gets segregated, they get distributed. So, cleaving a crystal, okay, so cleaving a crystal of an ionic component along a plane of ions, okay, then deformation of ionic crystal causes one of plane of atoms to the slide. Okay, here deformation of atom causes to the plane of the slide. Okay, and with this along another, and it results in the repulsive interaction between the ions. What does it shows? It shows the repulsive interaction between the ions. Okay, when which like change causes the layer of separation. So due to the repulsion, the separation takes place. So in this, cleaving a crystal of an ionic component along to a plane of ions, the deformation takes place. The deformation ion crystal causes from one plane of atom to the slide, okay, along with another. This will result in the repulsion, okay, repulsion of the plane of atoms to the slide with like charges, okay, जिसमें like charges होंगे वो इसको एक दूसरे को रिपल्स करना लगेगा, लाइक 1 to 1, 2 to 2, 1 to 1. दो जिन एटम्स का एक जैसा ही चार्ज होगा वो एक दूसरे को रिपल्स करना शुरू करेंगे, एंड आफ्टर इंटरैक्शन बिटवीन द एटम्स or ions with like charges causes the layer to separate out. Okay. So what are the properties of crystalline solids? अब crystalline solids की property क्या होती हैं? These solids have a particular 3-dimensional geometrical structure. तो जो पहली प्रॉपर्टी है आपके क्रिस्टलाइन सॉलिड की क्या है कि उसमें उसकी 3-dimensional geometrical structures होते हैं. The arrangement orders of the ion in crystalline solid is of long order. Okay, the strength of all the bonds between different ions or in molecules and atoms are always equal. Okay, melting point of crystalline solid is extremely sharp. Okay, जो melting point है वो इसका क्या है, crystalline solid का बहुत sharp है. Mainly the reason is that heating breaks the bond at the same time. जैसे जैसे हम उसको heat apply करते हैं तो जो bonds हैं हमारे same time पर break होना शुरू हो जाते हैं. Then the physical property like thermal conductivity, electrical conductivity, refractive index, okay, your mechanical strength of the crystalline solids are different along their different direction. Different in their different directions. Okay. So these solids are the most stable solids as comparing to the other solid. Which solids? Crystalline solid. Crystalline solids are the most stable solids as comparing to the another forms of solids. Okay. Now moving to the next topic of our today's lecture, that is amorphous form. What is amorphous form? You can see the definition is mentioned here. Amorphous solid do not have a specific shape. Amorphous solids का कोई भी specific shape नहीं होता है, because इसमें जो molecules, atoms और ions का arrangement होता है वो disordered होता है, जो कि हम पहले भी पढ़ चुके हैं. So an amorphous or non-crystalline solid is a solid that lacks the long range order characteristics of crystal. Example, glass, plastics and ceramics. Okay, so it is opposite of your crystalline. We can say it is also a non-crystalline type, or we can say amorphous. Amorphous in the Greek form it is known as shapeless, right? So here these are also known as supercooled liquids. These exhibit isotropic property. Isotropic property आपको इससे पहले बता दी. What is isotropic property? When it is there in a particular temperature, अगर हम एक पर्टिकुलर टेम्परेचर रखते हैं तो उस टेम्परेचर से वो सॉलिड फॉर्म में रहेगा, ब्रिटल रहेगा. जैसे जैसे हम टेम्परेचर फॉल करना शुरू करेंगे वो रबरी स्टिकी फॉर्म में आएगा, देन इट कम्स टू अ viscous and flowable property. So amorphous solids are like your particle, and the example is your cotton candy. Okay, you can see the example, that is cotton candy. Okay, now they are devote to sharp melting points. ठीक है, ये sharp melting points को devote करते हैं. No external regularity in their forms when these amorphous solids are formed. Okay, usually the amorphous solid exhibits irregular cut. amorphous में क्या होता है, irregular. If you like for example, if you take a glass and you will break it, it will be in irregular form. Okay, regularity is not there. Like in that we discussed in crystalline, like diamond, if you will cut with a knife, you will get a smooth surface on the top. But in amorphous form, if you will break, like example is glass, if you will break the glass, it will come into a irregular form. So amorphous solid do not possess any particular heat of fusion. जो आपके amorphous solid होते हैं उनमें कोई भी heat of fusion नहीं होता है. Amorphous solid do not exhibit rigidity. Okay? ये rigidity नहीं show करते. Deformation could be done by bending or compressing them. अगर हमको इनको deform करना है तो we have to bend them or we have to compress them. ओके मतलब ग्लास को अगर हमें एक शेप देनी होती है तो हम उसको एक पर्टिकुलर टेम्परेचर देते हैं, देन विल गिव अ शेप बाय डिफॉर्मिंग इट बाय बेंडिंग इट. ओके सॉरी, एज वेल एज इन प्लास्टिक्स ऑल्सो वी गिव टू अ compressibility and have a particular shape. Amorphous solids are considered as supercooled liquids or also pseudo solids. Pseudo means false solids. Okay, amorphous solids displays isotropism. Okay. Now properties of amorphism. Okay, yeah, amorphous form, properties of amorphous. The amorphous solid which are supercooled is called as pseudo solids. Glass is the best example of supercooled solids. Okay, the solids have irregular shape due to the orderly arrangement of constituents of particle. Okay, the solids have irregular shape. सॉलिड्स में क्या है, इरेगुलर शेप है. क्यों? क्योंकि जो ऑर्डरली अरेंजमेंट है पार्टिकल्स की, जो भी एक पर्टिकुलर कंस्टिट्यूएंट्स के अंदर है. द ऑर्डर अरेंजमेंट इज वेरी सॉफ्ट. ओके, इफ heat of fusion of such solid is not defined. Okay, if an amorphous solid is maintained at a temperature just below its melting point, okay, for long period of time, the component molecules, atoms or ions are gradually rearranged into a more highly ordered crystalline forms. तो amorphous form में अगर हम एक temperature maintain कर लेते हैं जो melting point से below होता है, वो भी एक लंबे समय तक के लिए, तो क्या होगा, जो भी हमारे मॉलिक्यूल्स हैं या हमारे जो भी एटम्स हैं या जो हमारे आयंस हैं वो ग्रेजुअली आएंगे. ग्रेजुअली आने के बाद वो रीअरेंज करना शुरू करेंगे एक हाईली ऑर्डर्ड क्रिस्टलाइन फॉर्म को देने के लिए. ओके, नाउ मूविंग टू आवर नेक्स्ट एंड लास्ट टॉपिक ऑफ दिस प्रेजेंटेशन. द थिंग इज दैट वी हैव द टॉपिक पॉलीमॉर्फिज्म. ओके, सो व्हाट इज पॉलीमॉर्फिज्म? इन दिस many substance may exist in two or more than one crystalline or amorphous form. Like बहुत सारे substance जो होते हैं वो हमारे दो, ठीक है, more than one, ठीक है, more than one in the form of two, in the form of three और many जो crystalline form में present होते हैं या amorphous form में present होते हैं. Then the phenomena where the component exists in more than one crystalline or one amorphous form is termed as polymorphism. तो जहाँ पे भी आपका component या आपका compound एक से ज़्यादा या तो crystalline form में अवेलेबल है या फिर आपका amorphous form में अवेलेबल है, तो उस चीज़ को हम polymorphism बोलते हैं. The phenomena when the compound exists more than one crystalline form or either in amorphous form which is also more than one. Okay, that term is known as polymorphism, and the different crystalline and amorphous forms as known as polymorphs or polymorphic form. तो जो different crystal या amorphous form हमें मिलते हैं एक polymorphism के अंदर, उनको हम polymorph बोलते हैं या polymorphic forms बोलते हैं. अब पॉलीमॉर्फिज्म सिंपली है क्या, ये एक वो सब्सटेंस होता है जिसमें एक से ज़्यादा, आपका चाहे तो क्रिस्टलाइन सब्सटेंस होगा या अमरफस होगा, मोर देन वन होगा, ठीक है, और जो एक से ज़्यादा हो रहे हैं तो उस सिचुएशन को हम पॉलीमॉर्फिज्म बोलते हैं. और इसमें जो सब्सटेंस प्रेजेंट होते हैं, ठीक है, जिनका डिफरेंट क्रिस्टलाइन या अमरफस फॉर्म के होते हैं, उनको हम पॉलीमॉर्फ बोलते हैं. और दिस इज ऑल्सो नोन एज पॉलीमॉर्फिक फॉर्म. The various polymorphic form usually arise through packaging of molecules in different array within the crystals or by difference in their orientation or conformation of molecule at the lattice site. So various polymorphic पॉलीमॉर्फिक फॉर्म्स क्या होते हैं आपके, ये जब अराइज होते हैं जब हम मॉलिक्यूल्स की पैकेजिंग करते हैं डिफरेंट तरीके से, ठीक है, जिसमें हम डिफरेंट क्रिस्टल्स यूज करते हैं या फिर डिफरेंट टाइप की ओरिएंटेशन हो जाती है हमारे मॉलिक्यूल्स की. Polymorphism is the ability of compound to crystallize as more than one distinct crystalline species with different internal lattice. Okay, so polymorphism is exhibited by 63% of barbiturates, 76% of steroids and 40% of sulfonamides. तो polymorphism जो है आपका सबसे ज़्यादा हमें देखने को मिलता है सबसे ज़्यादा देखने को हमें मिलता है स्टेरॉइड्स में, देन इन बार्बिचुरेट्स एज वेल एज इन सल्फोनामाइड्स. एग्जाम्पल वी हैव क्लोरमफेनिकॉल पाल्मिटेट, ओके, फिनोबार्बिटोन एंड crystalline form of spironolactone exhibit different shapes and properties. So this is the example. If an element crystallizes as more than one distinct crystalline species, the phenomena is called as allotropy. Okay, अगर हमारा कोई भी एक एलिमेंट है वो क्रिस्टलाइज करता है, ठीक है, मोर देन वन डिस्टिंक्ट क्रिस्टलाइन स्पीशीज, एक क्रिस्टलाइन स्पीशीज से ज़्यादा में, तो उस चीज़ को हम एलोट्रॉपी बोलते हैं. जैसे कि हमारे पास एग्जाम्पल है कार्बन, इट एग्जिस्ट एज क्यूबिक डायमंड और hexagonal graphite, okay, hexagonal graphite, and sulfur exists in two forms, rhombic and monoclinic sulfurs, okay, rhombic and monoclinic sulfurs. So various conditions in the crystallization process is the main reason which is responsible for the development of different polymorphic forms. Okay, the conditions are generally solvent effects, presence of impurities, level of supersaturation or temperature, or we can say change in the stirring condition. So the investigation of drug polymorphism is an important step in any formulation study because polymorphism may have a considerable influence on solid state property that may be modify biopharmaceutical and technological behaviors of drugs. So हमारा जो polymorphism है, ड्रग पॉलीमॉर्फिज्म जो है वो हमारा सबसे इम्पॉर्टेंट स्टेप होता है इफ़ वी फॉर्मुलेट एनी काइंड ऑफ फॉर्मुलेशन, बिकॉज पॉलीमॉर्फिज्म जो है आपका जो भी सॉलिड का स्टेट होगा उसको इफेक्ट करता है, इन्फ्लुएंस करता है, उसकी प्रॉपर्टी को इन्फ्लुएंस करता है, जिसकी वजह से आपका फार्मास्यूटिकल और टेक्नोलॉजिकल बिहेवियर जो आपके ड्रग का है वो ऑलवेज इन्फ्लुएंस्ड हो जाता है. ठीक है, सो पॉलीमॉर्फिज्म प्लेज अ वेरी वाइटल role in the formulation of drug molecules. So polymorphs control is important in drug discovery and development and is also required by regulatory agencies. So due to that respect या due to that reason polymorph का control जो है बहुत important है in any kind of our drug discovery because it directly influences the biopharmaceutical as well as the technology of a drug. ठीक है, biopharmaceutical means the kinetics of a drug, means the availability, bioavailability which is responsible for producing any therapeutical effect on the body. एक ड्रग जब बनाई जाती है तो वो पर्टिकुलर डिजायर्ड फार्माकोलॉजिकल एक्शन हमारी बॉडी पर प्रोड्यूस करती है, राइट? ठीक है, जिससे ही हम रिकवर होते हैं. तो पॉलीमॉर्फिज्म क्या करता है, उसकी बायोअवेलेबिलिटी को बायोफार्मास्यूटिकल्स को इन्फ्लुएंस कर देता है. ठीक है, तो जिस पर्पज से वो फॉर्मुलेट होती है वो उस पर्पज को मेंटेन या फिर रीच ही नहीं कर पाती है. सो पॉलीमॉर्फ कंट्रोल जो है बहुत इंपॉर्टेंट एस्पेक्ट है इन आर ड्रग डिस्कवरी एंड डेवलपमेंट ऑल्सो. ठीक है, जिसको रेगुलेटरी एजेंसीज बहुत ज़्यादा ध्यान देती हैं. डिफरेंसेस इन देयर इंटरनल स्ट्रक्चर्स ऑफ पॉलीमॉर्फ रिजल्ट इन देयर डिस्टिंक्ट फिजिकल एंड केमिकल प्रॉपर्टीज. तो जो इंटरनल स्ट्रक्चर्स होते हैं पॉलीमॉर्फिज्म के, उसकी वजह से पॉलीमॉर्फिज्म्स की जो फिजिकल और केमिकल प्रॉपर्टीज होती हैं वो वेरी कर जाती हैं. ठीक है, मोर देन 50% ऑफ API APIs is active pharmaceutical ingredients are estimated to have more than one polymorphic form. तो हमारे कितने 50% APIs जो हैं एक्टिव फार्मास्यूटिकल इंग्रेडिएंट्स, ओके, वो क्या करते हैं, सारे के सारे एक से ज़्यादा पॉलीमॉर्फिक फॉर्म में अवेलेबल है. ओके, नाउ स्ट्रक्चरल एस्पेक्ट ऑफ पॉलीमॉर्फ, configurational polymorphism is there, structural polymorph and conformational polymorph. तो configurational polymorph and conformational polymorph. Configurational polymorphs occur with molecules that have a relatively rigid conformation. Such polymorph have different 3D structure, example carbamazepines. Okay, then conformational polymorphs are what? Conformational polymorph occurs with drug molecule that have flexible structure. Okay, conformational में क्या है, flexible structure है, and the molecules can take various conformation, example ritonavir. Okay, properties of polymorphs are mentioned here, like packaging property should be there, thermodynamic property, okay, spectroscopic property, kinetic property, surface property and mechanical property. These are the some properties of your polymorphs which a polymorph have to be exhibit. Okay. Now, what are the types of polymorphs? The types of polymorphs are anisotropic polymorph and monotropic. Anisotropic polymorphs are when the change of one polymeric form to other at a transitional temperature is reversible. The phenomena is called as anisotropy and the polymorphic form are called as anisotropic polymorphs. Okay, example carbamazepine. Monotropy means monotropy occur when one form is stable and the other molecule is metastable. एक molecule तो stable है, दूसरा क्या है आपका metastable है. जो metastable होगा it will changes to the stable form. Further metastable आपका stable form में change करेगा at all the temperature and change is not reversible. तो metastable किसी भी टेम्परेचर पे स्टेबल फॉर्म में हो जाएगा और वो स्टेबल ही रहेगा, वो वापस से अनस्टेबल नहीं होगा. दैट इज कॉल्ड एज मोनोट्रॉपी एंड एग्जांपल इज क्लोरमफेनिकॉल, पाल्मिटेट एंड मिटोलाजोन. ओके, देन नेक्स्ट इज फार्मास्यूटिकल एप्लीकेशन ऑफ आर polymorphism. Now, what are the pharmaceutical application of the polymorphism? Preparation of physically stable dosage form, okay, influence on solubility, dissociation, okay, dissolution and bioavailability of a drug, okay, influence on drug product manufacturability, influence on stability and effect on tableting. Okay, so these are the application of your pharmaceutical application of your polymorphism. These are the references, okay, from where I have taken all the contents for today's lecture. And in today's lecture we have discussed on three broad topics, that is solid crystalline, amorphous and polymorphism phases. Okay, so with this I would like to conclude my today's lecture and have a good day. Thank you all.